Welcome to Unit 3, Lesson 1, Part 2, Angles and Their Measurements. So prior to this, we were looking at how angles either expressed as radians or degrees can change by adding 360 degrees to them. And now that we've done that, we have a formula for general form that will help us to determine the new angle measures for the coterminal angles. So remember, coterminal angles are in the exact same position as the original angle. It just depends in which direction and how many times you've gone around the coordinate plane to make that degree complement. So we have two formulas. It depends on the format that your angle is given in. So if it's given in degrees, we have theta plus or minus 360 degrees times n, where n is a natural number and we express it as n is an element of z, or all whole number integers. We also have theta plus or minus 2 pi, which is equivalent to one rotation around the coordinate plane, n. And again, n is just a whole number. So, for example, express in general form the measurement of angles which have the same terminal dimension as an angle of 110 degrees. Indicate the coterminal angles theta of an angle of 110 degrees in the interval negative 720 is less than or equal to theta is less than or equal to 720. So all we do is just plug in our values into this table, or excuse me, all we do is plug in our values into this formula, and then we can make a little table to help us figure out what the value of the new angle would be coterminal to the 110 degrees. So all we do is just plug in these -3, -2, -1 to show rotations clockwise around the coordinate plane, and 1, 2, and 3 to show counterclockwise ones. Now, based on the table, we have a bunch of values, but not all of them fall under our given interval of negative 720 to positive 720. So you want to look at the values you're given, and the coterminal angles that fit into that interval are negative 610, negative 250, and positive 470. Negative 970 and 830 are outside of our interval, so they're not valid answers in this circumstance. Now we can do the same thing when the angle is in radian format, and there's an example here. So here we're using the angle 8 pi over 3, and just that general formula plus or minus 2 pi n. So again, we're going to plug in some values for n and see what is the resulting angle. Now our interval is negative 4 pi up to positive 4 pi, and so therefore negative 10 pi over 3, negative 4 pi over 3, and positive 2 pi over 3 are all valid answers. Notice that negative 16 pi over 3 is not, as well as 14 over pi is not, because when you divide the denominator into the numerator, we get a value bigger than 4 pi. That's basically it for this general form formula. It's not really difficult. You just plug in the value of n and see where your values fall to give you the correct interval. Now, we also have a formula that we can figure out to determine the arc length of a circle. So in the top part here, we're going to talk about how did we get to this formula A equals theta times the radius, where A represents arc length. So we have two concentric circles with center O. So your O is right here. The radius of the smaller circle, so from here to here and here to here, is valued at 1. And the radius of the larger circle is r. We don't know how long that radius is. A central angle of theta radians here is subtended by arc AB on the smaller circle and arc CD on the bigger circle. So we have two proportions that we're working with. We have this first one, a over x is equal to r over 1. we're given that radius of 1, and then we have a bunch of unknown values. So when we just cross multiply this, we have A is equal to x times r. This is equation 1. Now, on the other side, we have x over 2 pi r is equal to theta over 2 pi. And when we sort this all out to solve for x, we will get something that looks like this. X is equal to theta over 2 pi times, sorry, it's going to go a little outside the thing here, 2 pi times the radius, which we know is 1. Okay, now 2 pi divided by 2 pi is of course 1, and then 1 times 1 is 1. So all we're actually left with on the right hand side is theta, and that's how we get down to x equals theta, because that given radius we have here, we plug in 1 as a value, and everything else just cancels out. So now we're saying x is equal to theta, or the angle, and therefore we can take this x equals theta and plug it back into our original equation, where x is, we can say that that's theta, or the measure of the angle. So therefore our formula to figure out the arc length becomes A for arc length is equal to theta, the angle, times the radius of the circle r. Now, there's an example here. Rosemary is taking a course in industrial engineering. For an assignment, she is designing the interface of a DVD player. In her plan, she includes a decorative arc below the on-off button. The arc has a central angle of 130 degrees, that's this angle here, in a circle with a radius of 6.7 millimeters. So the radius is given. We don't know how long the arc length, or A, is. So we're given some information and we need to plug it in. We first need to figure out what is the value of theta in radians. So we have 130 degrees is equal to 130 times pi over 180. And that leaves us with 13 over 18 pi. And that's a perfectly fine answer. We can work with that. Now that we know what theta equals, we can plug it into this formula. So we have A is equal to theta times the radius. We have 13 over 18 pi times 6.7. 13 times 6.7 is 87.1 pi over 18. And then just simplifying, we come out with 15.201. So it says nearest tenth of a millimeter. Make sure you watch your units here. And we have an arc length of 15.2. So from here to here is 15.2. An additional example, this is where it comes in really handy to make sure that you write down your variables and figure out what am I missing and what do I need to solve for, because your formula acts as a map. And if you use your map correctly, all you have to do is plug and play. So in this situation, we have an arc and its length is 3 pi over 2. We have a radius of the circle of 2. And we don't know theta. Thetas are unknown. So we have this original formula. A is equal to theta times the radius. And we want to isolate the theta. So A over R is equal to theta. Now, we'll just take these values and plug them in. We have 3 pi over 2 divided by 2 is equal to theta. Remember, when we're dividing a fraction by another number, we're just going to take the reciprocal and multiply instead, and that will give you a really easy answer to solve. So the reciprocal of 2 is 1/2. Okay, dividing by 2 is the same as multiplying by 1/2. And then you just multiply across the top. 3 pi times 1, 3 pi, and 2 times 2 is 4, which is equal to theta. So this angle is equal to 3 pi over 4, or approximately 2.356 rads. Beyond this, you have some practice questions that you can try before class tomorrow. And if you complete those, you should be on the right track to do well on your homework.